I'm hoping I will pronounce your names correctly. It's only recorded and will be put on the internet, so we'll see how that goes. I also want to make sure that, so I have a couple of announcements before we start. I think we've got one missing mobile phone. If you find one, grab it and take it to the desk or something. I don't know how to make that better. But be on the lookout for missing phones. We have 3 talks in this session. The way this will work is hopefully I will find you before it is your turn to speak, and I can get your slides. Or we have HDMI, we have other things as well. But I would like to know how you're going to present so that we can make it smooth when the time comes. We have 3 sessions in this, 3 talks in this session, but maybe only 2, depending on if we find an Ilari. We're going to have a group photo at 12:30. Jason mentioned this quickly. We're going to take it on the big stairs when we came in the front door. If you didn't come in the front door, there are big stairs over there. So go follow everybody else. We're going to do that at 12:30 after this session. It shouldn't take but 10 minutes. Yes, you have to smile. We'll see. Then we have lunch, and then we'll go through the rest of the day. And then I thought the agenda was going to be on the back, but it's not. It's on a different piece of paper. So tomorrow will look similar, and we'll get better at it as we go. I will now introduce our next speaker. So our next speaker is Paul van Schayck. He is from Utrecht. No, he's from Maastricht. I'm sorry, I saw the logo. He's going to be talking about providing validated, templated, and richer metadata using a bidirectional conversion between JSON and iRODS AVUs. Paul. Where's the button? On top. It's good.
Can you hear me? Hello? Can you? Yeah, in the back. Okay. Yeah. So thank you, Terrell. So this is a whole big title, and I hope I can break it down to something simpler. In the beginning, I had a simple iRODS AVU JSON with 2 arrows between it. That basically summarizes the whole presentation. So metadata. Metadata has been a big topic in iRODS, and basically any iRODS implementation that we see has some form of metadata handling in it. All using iRODS as a core. And so the group of people, for example, in the metadata templates working group, so Maastricht, UMC Data Hub, Utrecht, Yoda, MetaLinks, and Cyphers, have all been dealing with this metadata differently. How to provide the templates, how to provide the user interaction, how to do the validation. And we were looking into a generic way. And another big reason is this whole FAIR business. You've probably all heard about it. And so within the FAIR principles, it also states that you need to provide these community standards. You need to be able to adhere to those. And we were looking for generic ways to solve this issue. And that's this topic that we're dealing with. So metadata in iRODS, what is currently in there? Actually, it's pretty straightforward. You've got your iRODS object. This can be a resource, a user, an object, or a collection, or even a custom type if you do such a thing. And you can add any number of AVUs to it, attribute, values, and units. So these are triples. You've got the attribute, the value, and the unit. Most of the time only the attribute and the value are used, but occasionally also the unit is being used. So there's a few limits to this. And people, like for example, it's hard to do nesting, to do arrays within AVUs. So there have been different implementations how to solve this. And there's also no clear way how to template this. So there's no template for this. So we started looking at JSON. Perhaps the wrong JSON, so we started looking at this JSON. So why JSON? JSON is flexible and easy. Not that JSON. He's not even in the room. So too bad. So what does JSON offer? Nesting and arrays. You can see on the right, I think most people are familiar with JSON at this point because it's being used so much. It's being used within iRODS in many of the not within the AVUs, but in all the other parts of iRODS, it's being used more and more. Maybe some purists will come along and say, well, XML does all that and even better. But maybe something what puts me off with XML is that it's actually not very developer friendly. And developer friendliness is also something that's important. And I think that's why JSON took off a lot more. There's a couple of other things that we really liked about JSON, which is schema, and I'll come back to that can provide the validation, and even the UI presentation. And something else that, I'm not sure you're familiar with linked data, the concept of RDF and where this comes from, but JSON LD is a nice extension to JSON that provides also this linked data. I won't go further into JSON LD, but just to know that this whole work is compatible with JSON LD. So we looked at this and started thinking that we need to approach this with different layers. So we wanted to build this in such a way that you can take from this project, this piece of code that we've developed, you can take a particular layer and only use those layers for your application. And that's really the core is the conversion between metadata in JSON used towards AVUs, and this is bidirectional. So you can convert from AVUs to the JSON, from the JSON back to the AVUs. That's at the base layer. On top of that, using the template within a JSON schema, we can provide the validation. And during the conversion, the metadata provided is validated, and only if it's valid, it's ended up as AVUs. And then finally, the top layer, the presentation layer, which provides, so we can use the JSON schema to provide form UIs, and I'll have a small demo of that at the end of the presentation. And then the form UI, of course, outputs the JSON which gets converted into the AVUs. So we had a couple of design requirements when going about this, and one is a nice word that Tom, who collaborated on this project, Tom Smela, introduced to me is bijection. Apparently it comes from mathematics, but it means that any JSON any JSON you convert to AVUs is the same JSON when you convert it back from the AVUs to the JSON. So bidirectional. We also wanted to make it lean. We didn't want to, you can go about this in many different ways, but we didn't want to explode the AVUs unnecessarily. You can use many AVUs to do the conversion, but we want to keep it lean. Another thing was that we wanted to keep the attribute value pairs, which exist in JSON, the same. So we want to have, we didn't want to modify any attributes. We want to keep the attributes the same and then the value that is attached to that. Compatible with existing AVUs, so if you have any number of existing AVUs on your object, they're not affected, and they also don't interfere with the conversion. And as I mentioned, compatible with JSON LD. So this is it. This is the conversion. And I'll go through it step by step because it makes it easier. So we start with this object. It's got an attribute called title and the value hello world. So that ends up like this in the AVUs. And you see this, so we use the unit field for a lot of the, the context to do the conversion. So you see right now it's this, and I'll come back to that, why that is. So then we have a nested object on the attribute parameters, and then so that ends up like this. It's a parameter, it's O1 for object 1, and then the two attributes size and read only. So the 1 here refers to the value here. So that makes it so that how we make sure that these two belong to each other. But you also can see that the attribute and the value is still the same as it is in the JSON. So an array. So So 2 authors on this, and so here again we use the attributes and the value is the same, but then the unit using this hash and the number indicates the array index. Finally, an array of objects. You do basically a similar trick as you combine all the tricks that we saw before. You create the object, and this points that it's the first object in there, the first element in the array. And then the title and the DOI are again simple elements of the object. So the unit field we abuse for lots of different information. So far you saw only root being used. We call this the JSON root. This is a term we came up for ourselves, and what it allows us is that you can have multiple JSONs on the same object because you can put any name here, and only that name will keep all the different elements together. The parent object, so that refers to the parent object within the JSON, starts at 0 and then just increments. The type, so within JSON there's many different types of variables, while in AVUs there's only strings. So we have to account for that. So there's a whole bunch of different types: objects, strings, booleans, numbers, nulls, and empty strings. AVUs don't allow for empty strings, so we have to come up with something with empty strings. JSON does allow empty strings. And then finally the array index to keep all the elements in order of the array. So the implementation of this, we've got a simple Python pip package, standalone from iRODS. It doesn't know anything about iRODS. It does the conversion. It's on GitHub here. And then we've got the rule set. The rule set is actually what does the conversion. Not the conversion, but the interaction with iRODS. And what it provides is so it's also written in Python. So you need the Python rule engine to work. It provides 2 very simple functions, and these are the signatures. Set JSON to object, the object type, the JSON root you want to use, and the JSON. Get JSON from object type, and the JSON root that you want to extract. I guess there's now a demo, yes. So let's see if that works. Oh. So we've got 2 files in here, test2 file and test file. I'll only use test file for now. And I've got a JSON file. Oh, that's the wrong command. So I've got this JSON example file. It's the same example as I just showed in the presentation. And then using the rule, I'm going to set this JSON to the object. So you've got the JSON string, which I've put here, the object type, and the test file that I'm going to put it on, and that's now there. So if I now do an imeta ls minus the test.file, you see a whole bunch of AVUs set on the object, and now the real test of that is to also retrieve it again. So I do the get JSON, again the same parameters. I pipe it through to Python through just to format it slightly nicer, and you see you've got the same JSON back that we just set. The order is slightly different of the attributes, but that's actually the order of the attributes in an object in JSON are not fixed. They can change in order. It doesn't really matter. The order of the arrays is the same. So what's now nice is that you can also, instead of just getting this whole JSON back, you can also say, well, I just want the size AVU. And if you just want the size AVU, the value of that is this 42. So, and Ilari just showed up, so that's good. Welcome. So I'll keep my demo shorter than so that Ilari still has time. You can do similar with the authors, and you'll get two AVUs, both that were set. So all the things you can do is setting multiple JSONs on the object using different routes, but I won't show that right now. So validation, it's the next step. Like I told before, we've got this JSON schema, and we do the validation through that. So what's JSON schema? If you haven't seen it before, it's also not officially, it's still in draft, but it's been used in many different places. It's a vocabulary that allows to annotate and validate JSON documents. So you see an example of a person, you see the properties that it can have, a first name, a last name, and an age, and required are the first name and the last name. So that this piece of information allows you to validate the JSON document. And it's JSON itself as well. So, a bit of a complicated slide. How do we implement the validation? Yes, we've got the iRODS object, and we attach a special AVU to it. Attribute $ID, the value is a URI, and then the unit is the JSON root that we want to use for that particular JSON. So the URI can be an iRODS object to the schema, or it can be an actual URL to a resource somewhere on the web. Then, if you go through the default way of editing metadata, we are using the PEPs to validate, to trigger, to see whether this is part of an existing set of JSON. We call this protected AVUs, and those protected AVUs will then not be able to modify through the normal means. So this route will cancel out if it's attached to any protected AVUs. If it tries to modify any existing AVUs, it will just modify those existing AVUs. If you use setJSON to object to modify your AVUs related to, or your JSON related to which has been set using the $ID AVU, then it runs the validation. So it goes here, it runs the validation, and then sets the metadata AVUs. It's important maybe to note is that we do it. We remove all the existing AVUs and add them back. So it's this is a way to ensure that we get rid of any AVUs that are removed, or any JSON elements that have been removed, and only add the new ones. So this is also implemented in the same rule set. And so there's two extra function signatures available in that. It's the JSON schema to object, the get JSON schema from object. Again, you set the JSON schema URI, the JSON root you want to use, and this will give you back the actual content of the JSON schema. And then we use the PEPs, all the different PEPs to control, to provide the policy for not being able to modify any JSON AVUs that are protected. So just to give you a quick demo of that piece. So we've got let's show you is we've got this JSON schema here on the web, and what we're first going to do is, so this is the one that I showed before with the age and the person, a slightly simplified version of that, and we're going to set this to our test2 file. So set JSON schema to object, the object, test2 file, the JSON schema URI, and JSON root is root. So it's set, and if we now look at test2.file, it's set there. Just the $ID, the unit is root, the value is the URI. So now we're going to set the JSON object first name, last name, and the age to the same file, to the same iRODS object, and let's validate. So it has now performed the validation and it's valid. Maybe you don't trust me. I'll show you that if I provide something invalid. So let's change this to a string. The age should be an integer. It's now a string. You get an error. JSON instance could not be validated. Foo is not of the type integer. Just a simple test to also show you that you cannot modify any order. So if I do an imeta add to the same file and try to add something to this JSON, it will say MSI operation not allowed because you try to modify the existing JSON. So that was the validation. Finally, the presentation. So what's nice about JSON Schema is that you can extend JSON Schema with lots of other values in the JSON Schema that allow you to build up a form. And there's many implementations of that, unfortunately, so that means that this is not really a standard. So this is one of the possible libraries that exist that does this conversion, that does this in React.js, so it's for the web, but you could imagine that it even works on a non-web application. You have your schema that presents your form. So this is the generated form. So your schema also includes now a few extra things, so like the description, which allows you to build your UI. You can add this to the JSON Schema. So you've got your UI that you built, and you end up with with the form and also with the JSON that comes out of it. So we, and that's Utrecht University with Yoda and Data Hub at Maastricht University, have been a couple of use cases for this. For example, Yoda uses already forms built in React.js and defined in JSON Schema, and they're outputting JSON. Right now they're still doing a conversion to XML and store this as an object, and a whole bunch of conversion goes under the hood. But they were looking for a way to directly store JSON, so that's the use case that they have. We are looking at CEDAR. Probably not many of you have heard of CEDAR, but it's using JSON LD. So it makes use of the power of JSON LD to do the additional on top of the JSON. And they use an Angular JSON Schema form generator. So we have that use case. So I've got a quick presentation of, and it's more of a proof of concept of how you could use this, just to give you an idea of how this works. So what I'm going to do is go to the projects, and so this is a development instance of our portal, and to project 6, and let's say I want to change the project metadata which is on there. You get a form rendered, and this form actually comes from a JSON Schema which has been attached to this project 6. And just to show you, I go here in meta links to project 6 as well. I show the metadata set on this object, and you see indeed there's the $ID, there's the JSON Schema URI, and the different values that are in there. So if I change the update the metadata, refresh the meta links page, you see that that has updated in here. Another thing I can show you is that also from meta links it's not possible to modify these AVUs because you're not going through the setJSON to object call. We're using a trick for that. If you are interested in a trick, then come to me afterwards. Okay, so next, so on project 6 we have this URI. So if I now go to project 7, which for some reason doesn't exist here, interesting. Let's see if it does exist here. Let's see if I can go to it hard-coded. Yeah, there it is. No idea what happened there. So here we've set, using the internal URI system, we've set this Dublin cordial JSON. And if you look now at the form generated here, it's a completely different form. So that's the power of this system. You can set your JSON schema to an object, and that form can be generated at that point. All right. Future. What other nice things you could do with this? Form builders. You can make a form builder that outputs your JSON schema. The guys from CDAR, which we're looking at, have already done that. So they have got a form builder that outputs JSON schema. Other nice thing that you can do is not only present the form UI, but you could also present the search UI. You could build your search UI from the templates that you've set. I've heard ideas about setting authorization on the AVUs using the JSON schema, which may be a bit, so putting echoes in the JSON schema. That may be pushing it, but who knows. So a bit of final thoughts on this project. Why not store the entire JSON in a single AVU? I hope I've convinced you that that's not really making use of iRODS. You can't do the querying of single attributes, single AVUs. JSON schema, I wish it was a standard yet, but it isn't. And then a few comments about the implementation and a few for the developers. Please make a unit microservice. It's in this issue. So we include this now with our own code, the microservice to set units. I think this should be in core. The PEPs for setting for controlling the AVUs are really difficult to use because they are not on single AVU modifications, but they include the wildcards. So there's probably a few edge cases still in our code that are not handled. Why not a single, if it's possible, a single PEP that is just being fired on each and every single modification instead of this whole bunch of PEPs. There is race conditions which you can have during setting. If you execute two sets at the same time, we can't do locking from this point in the Python code. So that's also an implementation consideration. Not a big one, but still. All right. To end, the acknowledgements. First of all, to Daniel, sitting in the room there. He's done a lot of the coding of this work, so big thanks to him. Also the rest of the Data Hub team. And from Utrecht here, Tom. So I think about this idea was floating in Daniel's head for already 2-3 years. And at some point, Tom, about a year ago, said, well, I think less than a year ago, said, we want to do something similar. And then we started working on this. And Laszlo also for his help and ideas and the implementation. And finally, the metadata templates working group. We talked about this a few times. And hopefully this is a start of templates. So hackathon, if you're interested this Friday, I've got a couple of ideas of things that we can do during the hackathon. Maybe your own applications could be used. Thank you.
Since we started a little late, we can have a question or two maybe. We'll just run into lunch by a couple minutes. No, lunch over questions. Oh, there's one. Wait a minute. Wait a minute.
I missed the parent, what the parent was for.
Hold on.
Sorry.
Hold on.
I may have missed what the parent was for, root then parent. Is that?
Yeah, so the parent is so because you can have nesting in also in objects within JSON, you need something to refer to your parent object, because otherwise you lose where this object belongs to. Otherwise you have to do something like using the attribute to maybe a dot in between just to separate them. But then the attribute gets very long and you get into limits there. And so that's why the parent is in there.
Okay.
Anybody else? Oh, look at this. Let's go to the middle first. Are you going to catch? Ready? No? Okay, we're going to pass. All right.
So what happens if someone actually uses the unit field for real units?
Yeah, So within JSON, that concept doesn't exist, so that's not an issue. So if for some particular reason you would put in this exact string in your unit field, then indeed it would collide. I don't think anyone puts this in their unit field right now.
Okay.
But if anything else is in the unit field, it doesn't interfere. So if you put foobar into your unit field, you'll be fine.
So it's in addition to this.
Yeah. Okay.
One more. Not really supposed to throw it to each other. This is how it's supposed to work. No, okay.
Okay. So I like the concept. Just one thing, basically what you're doing is having a serialization, and is there anything in those repos that keeps me from just not serializing between JSON and the AVUs, but whatever I would like? Does that make sense? Like right now you're just outputting JSON with the get JSON stuff from the AVUs.
Yeah.
But as I understand it, what you're basically doing is you get the AVUs, you optionally validate via the schema.
Yeah, only during set.
Yeah. But there is nothing inherently that would keep me from creating, I don't know, whatever binary format I have that would be a sidecar to something else. Or even if I have an NFS file system that is exposed, just generating a sidecar.json file that exists in NFS rods but doesn't really exist, just so people can get those files. There is nothing that prohibits that. Am I making sense? Like
Yeah. One of the things that we thought at some point is maybe you have a file, metadata.json, which contains the converted AVUs. So on disk it's 0 bytes, but when you access it using iRODS, it's immediately converted into this JSON. I think there's something similar to your idea.
Yeah, exactly. Like if you make it read-writable, you could basically expose that to the user and have NFS metadata aware, so to speak, even within all of the iRODS AVUs.
Yeah, I think you run into lots of little issues there. But no, nothing prevents that.
Okay.
Yeah.
All right. Thank you very much.